There we go. All right. Well, thank goodness somebody's smarter than I am. So, yeah, that's not hard to do. Okay. Well, I just wanted to thank you all for joining and taking advantage or disadvantage of this virtual meeting. I think all of the information that I sent out, we had the agenda as well as the previous tag notes. If there is any changes in the tag notes, just send your corrections or changes that you want made to my email, and we'll get those updated. Last tag meeting, we didn't get an accurate list of folks that attended. So if you recognize that you were not recognized by your attendance, just text that into the whatever the field that you can type it into here. And same goes for any questions that you have during this entire meeting. It's probably easier if you just type those in, and then we can try to go over those rather than people interrupting and trying to talk over each other. I've noticed that in a couple meetings, it's hard to just hear what people are trying to say if there's a couple folks trying to do that, which is a disadvantage doing this online. But it's a lot easier and makes a lot more sense to do it with typing in the caption. So just as a heads up, we at GSLEP and the Division of Wildlife is going to update our website in the next few months. So there might be some difficulties when you get on our website. It will change as far as the format goes, or it'll be a little different than what you're used to. So if you do get on there and it doesn't look the same, the reason is we're trying to move into a little more user-friendly structure. And so I would say by the next tag, we'll have that finished, and you'll be able to see that and see the new format. So just as a heads up. So I think I've done this in the past. I've mentioned this before, but every few years I like to do it just to inform people that aren't aware or maybe confused about some of the things that we do here at the TAG. It is, if you are familiar with the Division of Wildlife Resources as a whole, typically our process goes through what's called a RAC and board process, where the RAC is a regional advisory council, where you have individuals that are members of the RAC that take input from the public, groups, general people that come to those regional advisory council meetings. They are allowed to make comments, and the RAC then provides a recommendation to the Wildlife Board. That the division also provides recommendations, but the board ultimately makes decisions on rules or policy for the division. So similarly, at least, and this is my own personal way of doing our tag, and if somebody ever tells me to do different, then maybe we will do it differently. But I see our technical advisory group in a similar role as the regional advisory councils. We have experts here that get together that take into account comments that are provided by the different folks here. I know sometimes people say, why the hell do I even come to these meetings, or what's the purpose of this tag? The agenda is basically the same every time, and at least the way I see it is we have 3 tag meetings every year. There's a pre-harvest, a post-harvest meeting, and then a mid-season meeting, which is the research meeting. The pre and post season meetings are basically just informative. They don't change. They are updates from our contracted researchers. This meeting specifically is about that research and is more specific to the research that we will be hopefully putting forth moving into the future, which is why I mentioned it's important to get the feedback from everyone to make sure that what we're doing is what's best for the ecosystem and best for managing the lake. So in a little different respect, instead of, or at least the way our research is done is once it's vetted through this group, the advisory group, we take that to what is known as within the Division of Wildlife as the Research Council. And the Division of Wildlife has a lot of checks and balances to ensure that they aren't funding or prioritize their funding for research so that they are funding the most important things. So the Research Council, again, goes through these recommendations that we'll provide and the research that we've put forth. And ultimately, the director's office decides whether or not to fund that and how it's going to be funded, because the director's office is responsible for our budget. And so there will be a prioritization of all of the different research that the Division of Wildlife undertakes. So whether it's migrating mule deer or it's brine shrimp research on Great Salt Lake, it still has to go through our director's office, which they essentially take into account the recommendations of that research council. So it's the timing for this is now, which is why we discussed this at this December meeting. Those recommendations are essentially due, and Gary and Corey and Mike have all gone through variations of this process to ensure that their research is funded and ultimately that it's been vetted through us, and hopefully because we have the experts that know the most about the lake here, then it's a fairly smooth transition to get that information funded. And that's probably why, you know, our meetings are typically the same agenda each time, and fewer outside folks join these meetings because it is fairly technical as the technical advisory group. And half the time I think Corey's talking over my head and I'm too dumb to understand half the stuff that's going through there. But that's why we have the rest of the group who are much smarter than I am and can provide input on research moving into the future. So I just wanted to kind of give that background on what we're doing. And both Corey and Gary have contracts in place because we typically go in kind of a 5-year cycle. Mike's contract with us is up for renewal. And the other thing that I like to emphasize is that we've maintained the continuity with all of the researchers, because this is such a unique system. And from the very beginning, there was essentially no information. And the information that's been put together over time has, in my opinion, advanced much better because of the continuity with contracted researchers, and because they have a vested interest in maintaining that relationship and understanding the system, which is so unusual, and have given us a lot. I think we've moved a lot quicker and stayed ahead of things. I've always said that the thing that I like about this program more than anything is that we're proactive in our management and our research rather than being reactive to problems. And that gap between being proactive and reactive seems to get smaller every year, especially with water issues around the lake. And I think that staying on top of those things and having our research answers being sought before they're asked by legislators or other managers around the lake or other water users. It's a big deal for us to get that information before they actually need it, because sometimes this research takes years, and obviously our program's been going for 25 or so years, and we have a good basis and have a pretty good understanding for most of it, but there's, as simple as it is, it's still really complex, as is evidenced by USGS's work with nutrients, which are extremely difficult to grasp and understand. And so it's good that we're moving in the right direction. It's also good that we're being still proactive, but to do that, we need to make sure that we stay on top of things. So that's what I kind of wanted to get from everyone, especially with Mike's research when he discusses that. I want to make sure that we agree that that is the direction that we want to go. And again, this is just an advisory group. It isn't a decision-making group. It is just to provide the best information to the Research Council and then our director's office for funding. So I hope that's clear. And Ben, if I was incoherent about the rack or board process or any of this, maybe you can clarify. Otherwise, I'll proceed. All right. So first up on the, yes.
Thomas, I do have a question.
Yeah.
So you did mention that the TAG was an advisory council, and I would like to know to which extent that the recommendations of that advisory council, the TAG, is taken into account by the Research Council in terms of their recommendations to your director's office.
Yeah, and I think if our section chief was here, he would probably be able to provide that, or if Frank was on the line, because he is, and I actually didn't see that. I'll answer it the best I can, but the Division of Wildlife takes scientific data-based decisions very seriously. That is the highest priority for them, and they defer to us because most of them, this, like I said, this is a unique system, so the experts are sitting on this meeting, and I think basically they do follow exactly with our recommendations, but they'll ask questions for clarification to make sure that there isn't any unnecessary expenditures in funding. And frankly, all it is me or the contracted researcher providing justification for the research. And once that question's answered, there's usually the recommendation goes forward.
Hey, John.
Yeah, Robert.
I'm actually sitting on the Research Council now and for the last couple of years. So I just wanted to add my 2 cents to this. I think by the time a project passes vetting by this group, it's pretty solid. And then my participation in this group will definitely help answer questions that come up during review of this process. And of course, the wildlife chief would be the primary, I imagine, for projects having to do with GSLEP. But that's all. A lot of projects don't get this level of vetting before they hit Research Council. So I think that's a pretty important part of the process.
Yeah, thanks, Robert. And that does emphasize, I think a lot of the research that the division puts forth is not vetted through an advisory group like this. It is usually it's just a recommendation by what the biologists or that region in particular think is appropriate. And so there isn't typically a group of experts that come together and put together these recommendations. So in my mind, just as Robert said, I think this is this goes above and beyond, and it typically goes through without any problems.
Thank you, John.
Any other questions?
Yeah, John, this is Corey. There's actually a question in the chat that Bonnie asked. It's a good question, so.
Thanks, Corey. I can read it. I'm just curious, John, how Laura Vernon's new position as Great Salt Lake Coordinator might impact the way GSLEP works or the management of GSLEP, or how GSLEP might work differently with forestry, fire, state lands.
You know, that's and Laura, are you on? I know she said she might be on. Okay, maybe not yet. Here's what I will tell you based on what I, or at least the way I take it. She's relatively new in her position, and I don't think any of us know for sure. However, I think it emphasizes the collaboration between the divisions and how we will be working much closer together as far as moving into the future. So whereas prior to this, I think there was a lot of do your own thing. You stay in this division, I'll stay in mine. And there is that element with the tech team where they're doing a lot of similar things that we're doing here, as well as they're providing funding for research. But I think with, so Laura is also on a department-wide water coordination group. And to be honest with you, she, in my mind, is a go-to when it comes to our tag group because she is over Great Salt Lake specifically. The difference with our group is we are specifically for managed for wildlife, and all of these recommendations have to do with wildlife, not with leases, mineral leases, or any Great Salt Lake specific activities on sovereign lands, but they're interconnected. And I think that coordination group, the water coordination group created by the department, has emphasized coordinating among the divisions, and that's advanced both groups, I think, so far, obviously with the creation of that job. So I don't know if that helps answer that question. It's a little...
Yeah, I think if it's evolving, that's fine. I'm just curious about conversations there that we're not privy to. So that's wonderful. Thank you.
Yeah, and I think you're probably...
John?
Yeah, go ahead.
No, I have a comment here, and I really do want to be on record that I'm opposed that GSLEP would be brought under the Great Salt Lake Technical Team. I think there's a huge amount of experience in this group, in the TAG, and in the Division of Wildlife Resources. I also think that the primary role of this technical advisory group is related to brine shrimp. That's how it was originally created. And I think the expertise is with the DWR and not with forestry, fire, and state lands. And from my perspective, I'm opposed to a shift like that. I think there are many ways to enhance coordination between divisions that don't specifically require a move of a very important advisory committee to a different division. That's my opinion. I want to be on record with it.
Okay, so maybe maybe you misunderstood. There is no way that GSLEP would be under forestry, fire, and state lands when it comes to, because we're in completely different divisions. What I was trying to emphasize is rather than competing with each other or operating independent of each other, we are coordinating aspects of lake management together, which is also part of this larger group, which is a water coordination group, which involves all divisions, not just forestry, fire, and state lands and Division of Wildlife Resources, but also water resources, water rights, everybody, every other division in the department is involved in that, which has increased the coordination and understanding amongst the divisions of what each one is responsible for and what they do. And just to your point, we are specific to wildlife. That can't change. Laura has no, I don't know if jurisdiction is really the right word, but it is more of a information sharing aspect to our position. And I think because she is specific to Great Salt Lake, whereas the tech team used to be kind of hit and miss in the past, there is an emphasis on Great Salt Lake interest and management. So sharing our information with her is nothing but good. But don't mistake that by me, or mistake it thinking that they would be somehow over GSLEP. I hope that's clear.
Yeah, that clarifies part of that, John. It's still my opinion that this is a well-functioning advisory group. And my experience is that when you bring too many topics under one umbrella, you sometimes get lost a little bit, and you lose your focus on what your primary focus should be by trying to encompass too many different areas of research. And it is my opinion that this group works really well, and I'm not sure how a change would benefit it. It may slightly improve communication between different divisions and different research groups, but I think it risks losing the focus that this group really has. And so my opinion is still the same, is that I think the way the group functions right now is efficient, and I don't see why it should change.
Yeah, and I'm not advocating for a change in the group or anything, and that's kind of why I described our process and why I explained that the agendas essentially don't change. The agenda occasionally will have a different speaker come in that may have a relevant topic that I think is can help inform some of the research here. But overall, it is the same structure every single meeting. We get updates from all three of our contractors, plus the shrimp demographic information. And and I know you sat in on the tech team meeting yesterday. Ashley presented some other research that was specific to a more ecosystem-wide approach as far as looking at some other managers within our program, which encompasses the waterfowl crew. And I think that's more what the tech team is focused on, is everything Great Salt Lake, not just this specific research that is focused on the brine shrimp and the birds that utilize brine shrimp, and primarily that part of the lake. So if there's a thought that we're combining or making a single entity, then that's not the case.
I understand that. I maybe, a final thought, John. I think you've done a tremendous job of leading GSLEP and of chairing the TAG and directing that research. And I'd hate to see that change.
Well, I appreciate it, and I don't think you will see that change. You can probably figure out what the next 10 agendas are going to be like, and it'll not be much different, but we'll just continue doing the same thing that we're doing until it doesn't work. It has worked, like you said, so far.
All right. Well, you haven't changed my opinion, but thanks for the clarification.
Okay.
Hey, John. Yeah, this is Corey. I guess I would just propose that when Laura does join us, maybe at the end of the meeting or something, if we could have her maybe speak to this a little bit and see what she thinks what her current vision of the role is, and how the things work together. That might be helpful and beneficial.
It's a good idea, and maybe I'll check as we're going through and transitioning from one presentation to the next. I'll see if Laura has joined and wants to provide a clarification. Okay, any other questions or things that need to be addressed? All right, well, then we'll move forward, and Kyle's going to hopefully share his screen and go over the shrimp demographics for this year.
There we go. All right, now everybody should be able to hear me. And now we should be able to present slides. Does everyone see the slides? I hope.
Yes, Kyle, I do.
Thank you. All right. So we're going to discuss the brine shrimp demographics, focusing on the time frame from the last tag. So moving from August through our last run in November. So looking at the average water temperature in the lake, we hit our peak there in August. It was quite warm, quite a bit above average. So to look at this graph, again, these are very similar to what we always present. All the colored squigglies in the background represent the years 2003 through 2019. The dark black line is that 17-year average. And then the prominent red line becomes the 2020 current year values. And that's going to hold through all of the graphs that I will be presenting on. So when you look at August, we were 27.4 degrees, so quite warm compared to that average. Then we noticed kind of this cooling in September and October, getting closer to the average and falling below the average. And then the really key point is in late October and through November, we're actually considerably lower than that 17-year average, showing that cold temperature in the lake, which is starting to affect the numbers of adults. And we're actually starting to see the die-off in our most recent December sample that we're processing in the lab now. And we should have new numbers by the end of the week. So currently sitting right about 6 degrees. So we're definitely hitting that transition zone. And like I say, into December, I think we've crossed below that 4 degrees where we're starting to see the adults dying off. Looking at salinity for the year, came into the year, had a relatively good spring with some inflow, low salinities early on, matching the average through the summer months. And now we're moving into this above average salinity levels, just with the lack of moisture that we've received this year. So even though we are a colder October, November, we're definitely a drier October, November than we've seen in the previous years. Currently sitting at about 14% salinity, so starting to push that threshold of concern. We really need some water. Looking at the chlorophyll values for this year, we had the ups and downs throughout the summer that plays in with these demographics and leads to some of the shrimp production, and we'll talk about that. And then when we look at the current values since August, so we had another peak in September, bottomed out in October. That's going to lead to that starvation for our primary cyst production through October. And then looking now, we're definitely on the rebound, and we're rebounding into areas that we have well above the average for this time of year. And that doesn't look to change very much. We've got a lot of summer months right now. That's one thing with the lack of storms, is we do have a lot of sunshine, which should help produce some good food base in the lake. So we should start with pretty good chlorophyll values, hopefully coming through January and February. So a little bit of a projection there, but hopefully we'll set ourselves up for decent food base next year. Looking at the total adults versus the chlorophyll, and I just want to point out that Ashley was super excited to get this graph done finally, because her R code was giving her some problems, and so now she can overlay graphs. So this is an awesome thing. Thank you, Ashley, for getting this put together. This really shows the highlights of how the chlorophyll values can affect the total adults, and how the total adults can in turn affect the chlorophyll values. So A lot of the peaks in chlorophyll will correspond to a trough in total adult numbers. So that little peak in September was because we saw an early die-off with that cold. We got that last generational rebound for total adults as they go up. And now we can see since October and through November in that cold time, we're actually seeing the die-offs and allowing the chlorophyll to rebound. Moving on to the cyst densities. So this year's been quite high. We came in fairly high over the summertime, you know, from in the spring, and then throughout summer, we've just always had high cyst densities this year, well above the average of the black line. Through August and September, we see quite a bit of early production of cysts and our higher cyst densities. And then you'll see the monthly averages on the left side. So for August, we were a monthly average of 125, September 157, October 187, and then in November 145. So we've been a lot higher than the average, but definitely not above any of the years over the previous 17. So it's one of the highest years, but not the highest year. So it's not outside of the realm of normal, just a little higher than average. Looking at the Knopley density, this kind of sets the stage for the pattern that we've seen this year, where we've trended really right on the average early in the spring, was below average through most of the summer, had a bit of a rebound kind of in the middle, and then now we've seen below average numbers as we move on through the late summer and fall months. And we're currently sitting well below average at basically no Knopley right now. So they've done producing generations, and that is to be expected with the cold temperatures. Looking at the juvenile density, there again, we saw that early peak in the spring, following that same trend, low numbers, below average numbers through the summer and fall, and then ending with currently below average numbers, sitting at basically 0 juveniles in November. Just a quick recap to kind of a quick view of the adult demographics. So the female density in the upper right-hand corner, the females with egg density, female density in the upper left-hand corner, female with egg density in the upper right-hand corner, female with cyst density in the lower left corner, which we'll talk about in the next slide, and then the male density in the bottom right-hand corner. So all of these kind of follow that same pattern of a little bit above average through the summer months and then dropping to below average through the winter months. So nothing terribly exciting there until you look at the cyst densities of here, which we'll highlight here with the females with cyst densities. We did see an early production of cysts moving on in June, and that was due to that chlorophyll drop, which we'll talk about in another slide here. We'll overlay this, and it shows that cyst production started early, remained high above average throughout the summer and through the fall, and is now below average with those cold temperatures as the adults are dying. And cyst production has pretty much ended for the year. Looks like it ended there in November. So the average females with cysts versus food. So this is the green line is the chlorophyll values, the black line is the females with cyst values. And so you can see they went through that starvation period quite early. The amount of shrimp that hatched early in the spring grazed all the chlorophyll down early by May, before the adults with cysts, the adult females with cysts were produced or achieved that at maturity. So they'd already gone through that bit of a starvation cycle, which likely triggered the early cyst production that we've seen this year. And then they've gone through several generations. You can see almost maybe 4 peaks of that, whether that's 4 generations or just, double brooding, not really sure, but they are getting early cyst production throughout the summer, and that has tapered off in December as the shrimp die off. The total adult density follows that same pattern that we've talked about, following the average right up and through May, and then just below average and currently below average as the shrimp are dying off. And with that, I will take any questions. If we can get those typed into the chat box. Take that. Get back to this. Okay.
No questions for Kyle? All right, Gary, you want to try to queue up your presentation, and I'll check. Laura Vernon, have you joined? I guess not.
I'm trying to get it to go. No, it's not there.
Hopefully we don't have to do the same process we did last time, but
Worked last night. Well, come on. Present now. There it is. Okay.
perfect.
Can everybody hear me?
Yes, sir.
Okay. So the data, a lot of what Kyle presented, I'm going to reiterate a little bit with the data, but one of the things that we've got now is all the phytoplankton counts are done through October of this year. And if you can see here, for 2020, we have gotten, compared to last year, the Denaliella, the chlorophytes, green algae, is going down much lower than it has in the past few years. And we're seeing an increase in the cyanophytes, or cyanobacteria, the blue-green algae, in our counts. And I'll be talking more about this later on in terms of what we're doing with the phytoplankton studies that are going on in our lab. One of the things that you can see here, as Kyle pointed out, is that there was a tremendous decline in the spring due to grazing by the brine shrimp to bring the phytoplankton in the lake down. That's the blue line. The average since 1994 is the red line here. And it was reduced by the grazing of the shrimp. And you can see through most of the summer that the phytoplankton was at a much lower level than what we've seen since 1994. And we can see here, as I pointed out, the phytoplankton normally go through various changes over the summer. This is by year, and this is the average in the phytoplankton. And the yearly variation is quite substantial since the project started in 1994, where we've had low years with the chlorophytes, the green algae, the Denaliella, and then the last few years it's been very high on average over the years. Early on in the studies, the diatoms, or bacillariophytes, hit peaks at various points in time and then have declined to low levels. We've seen the same thing with the cyanophytes, or the cyanobacteria, the blue-greens, and they have been at a fairly low level. But you can see that this year, at least, they're starting to rise again compared to some of the past recent years. This just is the same data that Kyle presented. One of the things that I'd like to point out that Kyle did not indicate is this big peak that we had in the juveniles early in the spring. And this is what really, I think, drove that demise, that decline in the phytoplankton for the summer months. And that increase, that high number of juveniles, did not match with a high number of nauplii. So at some point, the sampling in the lake missed a peak in the nauplii production with the periods in which the lake was being sampled. The rest of this is what Kyle presented. And to emphasize what happened this summer, let's calculate the shrimp population in terms of adult equivalents. And that's the number of equivalent adults in the population based on consumption of phytoplankton. And you can see the red line here is the average since 1994. The blue line is this year. And you can see that that peak of adult equivalent consumption is very, very high in the early spring, much higher than on average in past years. And then the adult equivalent number falls much lower than the adult equivalent number since the average since 1994. So we had very substantially greater consumption of the phytoplankton early in the year by the shrimp. And if you look at, you can see this as well, if we take 94 through last year, and the blue line is the chlorophyll in the lake by month. The red line is the adult equivalents based on consumption by month. And you can see, sure, each year there is a high peak. There's a peak in adult consumption in the spring that pulls down the chlorophyll levels. But if we compare it over here to 2020, you can see that this year that early adult equivalency in terms of consumption was very, very high. And from that point on, it went way down and held down the chlorophyll levels in the lake until the last few months when the chlorophyll, the phytoplankton, have started to recover. So now I'd like to move on to algal studies and reporting on this, which I started to present in August meeting. And what we have now is laboratory phytoplankton responses for 3 of the major phytoplankton players in the Great Salt Lake. The green line is for Dinelliella, the most common chlorophyte, green algae. The brown line is the response by the diatoms, and this is one of the most common diatoms in the lake, Nitzschia. The blue line is for cyanobacteria, blue-green algae, and this is for one of the most common blue-green algae in the phytoplankton, Euhalothaceae. I can never pronounce that right. But anyway, we've done in the laboratory how they grow, maximum chlorophyll that they achieve, number of weeks that it takes for them to achieve that maximum chlorophyll, and then the growth rate of the phytoplankton, of that type of phytoplankton, which is essentially this maximum value divided by the number of weeks that it takes to get there. And one of the things that we have it for temperature, variation in salinity, variation in nitrogen in the water, and variation for the diatoms, the bacillariophytes, the silica in the water, since they use silica to make their frustules, that glass-like structure that the algae is housed within. One of the interesting things that you can see here is that the Dinelliella does well at lower temperatures. The diatom and the blue-green algae does better at higher temperatures. The Dinelliella, the green algae, does well at high salinities. The blue-green and the diatom do better at lower salinities. And we can go on and see here that the Dinelliella, the green, does much better as nitrogen increases. The diatoms do better as nitrogen increases, but not as well as the greens do. And the cyanobacteria, the Euhalothaceae, doesn't do as well as either the diatoms or the green, the Denaliella, as the nitrogen increases. And that's an interesting finding because this particular cyanobacteria, this particular blue-green now, based on genetic studies that have been published for this particular genus of cyanobacteria, they have a gene that is associated with being able to fix their own nitrogen. So you would expect if they can fix their own nitrogen that they shouldn't respond as well to added nitrogen in the system because they're generating their own nitrogen. The time that it takes to get to the maximum abundance is not that different between any of the three categories of phytoplankton, but it does oftentimes lead to much greater differences than you would see in the maximum chlorophyll in terms of the growth rate, how much is being added each week. Now, the important thing here is that if you notice, the cyanobacteria, the blue-green, the brown line, the blue line, the diatoms, the brown line, and the green for the Denaliella, they are responding differently to the environmental conditions in the lake. And in August, I presented how this looked, what this looked like on an annual average basis, and it was suggested that why use annual values? Why not do the monthly abundances of the different phytoplankton in the lake and examine it on a monthly basis? So that's what I've done here, and this graph tries to point out. So let's take here, this is for the cyanobacteria, and the light blue box here is the range of conditions in the lake that have been observed since 1994 to present. Based upon our laboratory experiments, I have calculated here in the pie chart the proportion of the phytoplankton that should be composed of the three different categories. And then I've plotted here in the stippled region, which I hope everybody can see. So for the blue-green, it's this little rectangle up here. Those are the conditions in which that blue-green algae would be 20% or more of the phytoplankton in the lake. The unstippled area here is where they should be less than 20% of the phytoplankton in the lake. And you can see that the blue-green does very well up here at low salinities, high temperatures, doesn't do so well as salinity increases and as temperature declines. So you can see that the green dominates in three of the corners compared to the diatom and the blue-green. These points here are when we have observed on a monthly basis. The dots are when we've observed on a monthly basis that particular form of phytoplankton to be 20% or more of the total phytoplankton. If we go to the blue-green, we can see that not blue-green, but to the diatom, you can see that they can hit 20% or more on a greater range of salinities and the same temperature range as for the cyanobacteria. And if we look at Denaliella, the chlorophyte, the green algae in the lake, phytoplankton, the stippled area here is very, very large, and they do achieve 20% or more on a large number of the months that we have data for. So let's look at each one on a larger basis. We can see here that 79% of all of the Denaliella values are greater than 20% of the phytoplankton. They make up 20% of the phytoplankton and 79% of the 212 measures that we have. And 100% of these observations of 20% or more fall within the favored region here, the stippled region. And if we look at the conditions, we see that the observed values on a monthly basis are negatively correlated with temperature, positively correlated with salinity, and a very high regression fit to these data. And so that the Denaliella is responding primarily to lake conditions based upon temperature and salinity. Now let's look at the diatom, the Bacillariophyte. Phyte. Only 18% of the 212 monthly measures that we have for the diatoms achieve 20% or more of the phytoplankton. It's rare for them to be that abundant. And when we look at these values that are greater than 20%, we find that only 18% of them actually fall within the favored region of temperature and salinity. And if we look at the ones that fall within this favored region of temperature and salinity, we see that the values go up with temperature and decline with salinity as predicted by our laboratory experiments. But when we look at the area that's outside of the favorable region and look at those values that are greater than 20% there, we see a complete reversal. We see that those numbers are negatively correlated with temperature and positively correlated with salinity, just the opposite of what we see in the laboratory situation. And when we look at the monthly wind values squared, which is the stress of wind on the lake, that is the better predictor than either temperature or salinity on these values that are 20% or more and fall in the unfavorable region. This is what I pointed out in August that we saw when we looked at this on an annual basis. And I'll come back in a moment to what I think is going on here. When we look at the cyanophytes, only 21% of the 212 measures have cyanophytes greater than 20%, and 13% only of those values fall within the favored region. Always, the cyanophyte values are positively related to temperature and negatively related to salinity, which is what you would expect in terms of what we have in the laboratory experiments. However, when we look at these values outside here that fall within the region that's unfavorable, even though temperature is positively affecting them, salinity is negatively affecting them, we see that those values are highly correlated with the 3 last months of diatom abundance in the lake. So as diatom abundance increases in the phytoplankton, the cyanophytes increase as well. So one of the interesting things that we know now is that 2 of the diatom and the cyanobacteria that we've looked at in these laboratory experiments are also common constituents of the microbialites in the lake. Nitsia in the microbialites that we've sampled from the lake are 29% of the primary producers of the algae making up the microbialite, and Euhalocese is 71% of the microbialites that we've sampled. So what I've presented here is experiments I've presented in the past showing our microbialite measures of, let's say, maximum chlorophyll versus temperature, salinity, and nitrogen. And then I took our phytoplankton measures and multiplied those by the proportions here that each of the constituents make up of the microbialite, and then plotted that value, that's the blue line here. And it turns out that these 2 species of algae, or types of algae, on the microbialite, on average, are 54% more productive on the microbialite than when you have them free in the water column in our experiments. So there's something that is going on in terms of a buffering effect of the different, of the microbialite, allowing these two types of algae to respond better under sometimes less favorable temperature and salinity values. Well, if we take the pelagic part of the lake and calculate what the average density is of phytoplankton, and calculate what that phytoplankton production is in the water column, and then look at the abundance of microbialites and what the production is of the algae on the microbialites, we can calculate then what the production lake-wide is in terms of microbialite chlorophyll. And it turns out that the microbialites are providing about 4.7 times greater abundance of algae based upon chlorophyll A than we find in the phytoplankton. So these microbialites are 4.7 times more productive lake overall for the lake than we would get in the phytoplankton. And let's go then to see what I would argue, or what I'm hypothesizing is going on. Microbialite biomass declines by up to 50% over the winter. The chlorophyll A declines on the microbialite by up to 50% each year. It would take only 5 to 10% of microbialite chlorophyll A from the diatom and the blue-green or the cyanobacteria being released into the water to actually account for them to be 24 to 90% of the phytoplankton in the lake. So we also can see that 71% of those diatom values that are anomalous, that are greater than we would expect given they're in the unfavorable temperature salinity portions of the conditions in the lake, those tend to occur in October to March when water temperatures are declining. Remember, the diatom and the blue-greens do better in warm waters. Cyanophytes increase in abundance in a lagged fashion behind the bacillariophytes phytes, or the diatoms. And one of the things we know from published accounts of microbialites is that the diatoms, the bacillariophytes, given their silica frustules, that silica shell that they live within, provide rigidity to the sticky matrix formed by the cyanophytes, the blue-greens, that make up the microbialite surface. So what I'm hypothesizing, and started and pointed out in August as well, I am hypothesizing now that these anomalous years that, or months that we have, where we see lots of diatoms and lots of cyanophytes, blue-greens, may occur when winter temperature declines stress the microbialite. And if you combine that stress with greater wind stress on the microbialite, creating water action, wave action across the microbialite, this could lead to a release of the bacillariophytes, the diatoms, into the water column. And this later leads to cyanobacteria release because the structure is weakened without having the diatoms there. And so right now I've got this working hypothesis that these anomalous observations that we have when the diatoms are abundant and the cyanobacteria become abundant may be due to this process. This has important implications for the models that I'm building for the lake. And if the total production is not being affected so much, the model right now is predicting total production fairly well, but the model predicts pretty well the production of the green algae, the Donnelliella in the lake, but it's way off in accounting for the abundance. The predictions are red. The blue is observed since 1994, the averages, and it's way off in terms of those predicting those two categories in the phytoplankton. And so therefore, this is from what I've presented in the past. This is the phytoplankton module within the lake model. These are the two portions of that phytoplankton aspect of the model that need to be now modified with this data that we have from laboratory experiments. And this leads to how we have to link, perhaps, the microbialite production to come up with, right now the model is operating that temperature, salinity, and nitrogen are affecting the abundances of the diatom, the blue-greens, and the green algae. And yes, we can now, from the laboratory experiments, calculate those contributions in the phytoplankton in the water column. Green algae goes straight into the total abundance, but the total abundance of diatoms and blue-greens now also may depend upon what the microbialites are doing and releasing into the water column. And so this is adding another piece of complexity to our lake modeling program that is going to lead to the linking of the benthic microbialite with the pelagic portion of the system. And it's because it's this release here of the bacillariophytes, the diatoms, and a release of the blue-greens, the cyanophytes, into the water column. And that's what I have to present today. Happy to answer questions.
Anybody able to ask a question?
Gary, have you noticed, do you have data on if there's like a trend or a decline in chlorophyll over time? I think you have chlorophyll data going back a few years before we do, and I noticed your average was lower.
Yeah.
I was just wondering if it's like slowly declined at all, and if that could be contributed to lake loss, decline in lake level and exposing microbialites.
That would be an interesting next step to go to, looking at water levels. The problem that we're facing, well, can only do so much at a time. And so we're at a point now where it's, if this is going on, to see what the effective lake levels are in terms of this. What I'm calculating now is that all of this is based on calculations that the microbialites are sitting 1.5 meters on average below the surface. Okay, so that could be built in as another factor that would have to be considered, but right now, no.
Right, yeah, I was also thinking, you know, I'm sure wind increasing near the shallows would, but that's a whole nother thing, would hit them harder. But I know that that would be really hard to predict too.
So right now, doing this with just regression analysis, all I'm doing is putting in the wind squared, the speed squared, which is the measure of stress on the surface of a body that creates turbulence. And yes, that should change with the depth of the water, but I'm not getting into that level of detail yet.
Gotcha, thanks.
But your question of why we have lower, what was it you asked? There was lower chlorophyll per liter?
It seemed like from your average is lower than ours, and I was wondering if you've looked at chlorophyll per year by month to see like if there's a trend going down, kind of like lake level.
If you go, I don't know if I want to share again. There is that figure in that one slide that shows the peak chlorophyll A value by year. And in the early years, 94 through 99, it was real high, went down, then came back up in the early 2000s. Then it's come back down and has held fairly constant since that point in terms of chlorophyll A of the phytoplankton in the water column.
So is it trending down?
Value, that is the maximum value observed in any 1 year.
Is the maximum value trending downwards overall?
Yes.
Okay.
Maximum value is trending downwards from the early years of the GSLEP studies.
Okay. Great.
That started in '94. Yeah. Other
Chris,
questions?
I noticed you asked a question, and I think Gary was kind of touching on it. Did you want to?
Yeah, I'm just curious if it, like if the square kilometers, square meters, some area measurement of microbialites is known, active microbialite versus microbialite that is stranded, basically high and dry. And if it's, if you've done anything to kind of correlate that increase, either modeled or observed with the area of microbialite that is functional.
Yeah, I came up with 700 kilometers squared of microbialite, and that was what the figure was that Rob Baskin came up with and published.
Okay.
And that's all I'm using at present.
Okay. So as that number goes down, since it's almost 5 times more productive, that could have like a really significant effect on chlorophyte populations year round, or is it kind of a seasonal influence, do you think? Or since it seems like this is more of a low temperature, high wind situation?
To a great extent, it is seasonal. As I pointed out, 71% of these values, at least with the diatoms, occur in the winter months.
Right.
And that would indicate that it's probably cold stress, because over the period, those same periods, it's over a wide range of salinities.
Right.
And so that would suggest it's cold stress that's probably doing this.
Okay.
I mean, one of the interesting things that is emerging out of this is the dynamics on those microbialites, and Bonnie, I know, is interested in this. There's a possibility that a lot of that biofilm that is left behind could be left behind by dead primary producers as well, that are dying off in the winter time and then getting regrowth again on that surface, and it's accumulating over time.
Okay.
I don't know. It's just an idea that because we do know they're dying off on a regular basis each.
Right.
I don't want to say dying off. They're declining on a regular basis every year.
Does that increased, concentration of chlorophyll that's related to the release of those chlorophytes in the winter, does that have any, implications on the setup for spring conditions? So if there's less of that pulse in the water in the winter, does that have any effect on, what happens in the spring, like what's available to get growing again? Or is it kind of more of a within winter response type of thing?
We know right now that in each month, if there's a lot of diatoms in the water column, the shrimp don't do as well.
Okay.
So it's possible that if you had a severe winter and high winds and you had a big release of diatoms, that the shrimp might not do as well in the spring.
In the spring.
I'm hypothesizing this right now, but we do know there is this correlation there.
Okay, thank you.
I want to point out from what Kyle said and what I presented in terms of the demography this year, the reason why cysts are so high is because of that severe starvation that took place early in the year and the shift to cyst production rather than live young. Any other questions?
All right.
Thank you.
Bonnie, did you want to mention any other research that is being funded by Forestry Ferret and State Lands, or?
Yeah, I first wanted to, I put it in the chat, but I'll say it out loud. Gary's a great science papa. He mentored another graduate student to her defense on Friday, and Kate did a fantastic job. And I know that Friends of Great Salt Lake, she won the Doyle Stevens Award, and just a lot of people have met Kate and been involved in her work. So I thought this group should hear how proud I am of her and Gary's work on this. So I think that's awesome. I've been working with Eric Boyd's lab in Montana this year on a grant from Forestry Fire State Lands to measure primary productivity and secondary productivity in the microbialites. And we're doing 4 seasonal samplings in open water and microbialites, and we're measuring chlorophyll as a proxy just so we can relate that to work that's been done in the past, but we're looking at carbon assimilation in radioactive assays that are done on the lake shore, right, as because you can't do that in the lake. So we're looking at carbon fixation. We're looking at chlorophyll. USGS is running a nutrient study on those same sites, all their nutrient parameters. Soren Brothers at USU has been coming to every sampling because he also was funded to look at primary productivity this year. So we're trying to coordinate our work as well. Anyway, it's like 4 days out of the course of the year, but the amount of data we get at each sampling is really intense. So I hope this time next year we'll be able to give you really a good story about all that.
Awesome. Thanks.
Talking about Kate's dissertation defense, I also wanted to point out one of the people that's on the meeting today is Andrea Stump, my new Great Salt Lake technician. So she's participating today as well. Hi, Andrea.
Welcome.
Hi, thank you.
Anybody else have any questions for Gary before we move on? All right, other than cloning Gary, I guess we'll move on to the next presentation by, I assume it's Corey and not Ryan, since I didn't see Ryan on here.
We're actually going to be having
Christine.
Yeah, Ryan is
okay.
on now, but yeah, we're gonna switch between the 3 of us, and hopefully we'll be able to do this smoothly, and so that we all look cool and like we know what we're doing here. So, hey, and just real quick, John, I did see that Laura Vernon is on now. I don't know if you want to do that conversation now, or if you want to wait to the end.
Yeah, no, let's, while you're pulling up your presentation, I'll quickly ask Laura if she can look at the chat box. Bonnie, you can ask the question that you asked originally about how the relationship with the new coordinator and how that impacts GSLEP. I don't know if you saw that, Laura,
Yeah.
but
Yeah, Laura, when we first started, John was giving sort of a history of TAG and the way it works, as he likes to do in the December meeting. And I thought it was really well done. Thanks, John. But I wanted to understand maybe how your new position might change the way things work at DNR with respect to this special program and your job and your oversight of all things Great Salt Lake, and how you see that working.
Yeah, thanks. I'm sorry I missed the first few minutes. Ryan and I were both on a drought monitoring meeting with the Division of Water Resources, so I apologize for that. But to answer your question, Bonnie, I think the connection remains to be seen. It has not been defined yet, and I am completely open to what it could look like. You know, I think starting this new gig in a pandemic, there's been a lot less, there's been far fewer face-to-face discussions that I would have liked to have had, which I think would have been with John and other people, you know, just as a side of how we should connect these groups going forward. To be honest, you know, in the past couple of years, when we talk about all the different groups on the lake, I feel like the tag is kind of like hanging out on its own, and this group does an invaluable work for the lake, and I don't want to underplay it. And you know, the value is tremendous, and I want to make sure that it continues on and just build on it, and maybe build on the communications that, you know, what happens as a result of what's going on in this group, what happens on the lake, how the lake is thriving or not thriving. Maybe getting that word out to a bigger audience could be an option, but I'm totally open to having that discussion. If there's a group of people in the tag that want to meet to talk about what that could look like, I'm open to that. So.
Does that help, Bonnie?
Oh, it certainly helps me. I appreciate that. I think it's good to think of it as plastic and evolving around conversations that are useful. I think that's good.
Yeah, and Laura, I just kind of mentioned our water coordination group that's DNR wide. So it's, I think the emphasis was that we have increased our coordination as well as communication among the different divisions, and I think that's what the benefit is, and I think part of that is just the creation of that position. So it all seems like that's done nothing but improve all divisions and the department-wide emphasis on water.
Yeah, I'm astounded. I think that Water Council group is going to be super helpful moving forward. So I'm thrilled that Director Steed is on board with that, and I think he's super motivated to be involved and to see that that group is communicating effectively. As far as my role, I think what I'm seeing over the last couple months is that you know, the communication between DNR is one sphere alone, and then you have these other different spheres that I would say the industry and kind of stakeholder sphere, and now in a new world to me is kind of the watershed sphere, where we're looking at what's happening upstream. And I just, you know, working at Forestry Fire and State Lands and on the bed of the lake, I haven't looked upstream that much. So I think there's these different spheres that all require attention, and that DNR one that you speak about in the Water Council is really helpful, because that's a full-time job in and of itself. I feel like sometimes communicating between the DNR divisions. So if anyone has any questions or thoughts about, you know, Great Salt Lake as it relates to the rest of the world, just reach out anytime.
Thanks, I appreciate it. Hopefully that clears up that question, or gives an idea of what Laura's role is, and obviously that will be somewhat adaptive moving into the future, having been a newly created position.
Super adaptive.
Okay. Yeah. So with that, we'll move into the three-part USGS, or the three-pronged attack from USGS with Corey.
All right, thanks, John. And you should be seeing my screen now, right, John? Yeah.
Yes.
Okay, great. Thanks. And yeah, so we'll just get going here. And I'm going to give the first part here, kind of talking about the lake level and kind of history on that. And then we'll flip it over to Ryan. We'll talk about some of the other monitoring that we're doing on the lake. And then finally, we'll give it over to Christine to provide the meat and potatoes of this presentation on the nutrient work that that she's been doing, the nutrient study out there. So with that, we will go ahead and get started. So where we're at for the lake level. So today we're at 4192.2. So remember that the historic low that was reached in 1963 is 4191.35. So we're less than a foot away from that. Typically this time of year is about the lowest that we see the lake. And then, you know, it will kind of stay steady through the winter and then start going up with the spring runoff. So hopefully everybody should, I think what we need to do is we need to get a weather service person in this group. So that way, when we want more water, we can just ask them to make that happen for us. I think that's in their bailiwick. So anyway, maybe that's something to look into, John. So, and we're down about a foot from where we were in August, which is not too uncommon. And let me go there. And we're down about 1.3 feet from a year ago. So if you look right here, that was last year at this time. We're down here. So we're back about to where we were. We're actually a little bit higher than where we were in 2018. We had a good runoff year in that spring of 2019. So let's hopefully we will get another one of those this year. If you look at the long-term record, so this is back 10 years or so. We've been on kind of a decline. Had a good water year here in 2017, another good water year in 2019. But you can see last year wasn't great, and so you know we came up a foot and a half last year, where the year before we had come up about 3 feet on the lake. So again, whatever we can do to get more snow in the mountains would be much appreciated. And then this is the long-term one. So this is back in 1963 when the historic low of 4191.35 was reached, high stand of the 80s, and kind of where we're at now. So there you go. And then if we look at saline, so the north arm of the lake, we're at 4191.8. So again, down about a foot from where we were last year. And we're at about 0.4 tenths of a foot head difference. And that's what really drives the flow from the south to the north, and then also creates the opportunity for the north to south flow to occur at the breach, which Ryan will be talking about here. Yeah, so this is where we were last year, and again we're similar to where we were back in 2018 at this time, and then that's the last 40 years or so, 50 years of the north arm data. All right, any questions on that? I'm going to stop sharing here, and then Ryan will be able to take over and talk about the next part of it. And I guess while Ryan's getting that set up, well, Ryan's already got it going. So go ahead, Ryan, take it away.
So you guys see you see a slide? Okay.
Yeah.
Cool. All right, so there's Corey's last lake level slide. So moving on to some of the additional monitoring we do, just to remind this group that we do a lot of discharge or flow monitoring. We have continuous flow data at the Weber River, and you can see on the map where these are located. The Weber River, Farmington Bay outflow, Goggin Drain, Great Salt Lake breach near Lakeside. We call that the old breach. So for those sites, we have continuous flow data, full-blown stream gauges. And then we make periodic flow measurements at Bear River Bay outflow, and then at the new breach. As we all know, this flow data is just fundamental to understanding the Great Salt Lake system. So we just need to keep reminding ourselves of the value of this investment that we all make into the flow monitoring. A little more on the new breach. This is a key site, as we all know, for managing Great Salt Lake and the salinity levels especially. So we are making monthly flow measurements there during calm conditions. We've been doing that since December 2016. But our goal is to get a continuous flow record generated there. And to help us along the way, we're working with the USGS Hydrogeophysics branch to install a resistivity sensor chain, which, the inverse is conductivity. So this is basically a conductance chain that we're going to install at the new breach. It's going to span the water column, span the lower salinity south arm water through the boundary and into the deeper north arm water. And we're working to get this deployed hopefully early in 2021. So this is going to be a significant development for this site. This is going to offer us the ability to identify the depth of the boundary layer between north and south arm water more accurately than we're able to do with the acoustic Doppler instrumentation that Corey discussed during our last TAG meeting. And so that's going to help us improve our continuous discharge measurements at this site quite dramatically. So this is a big development for us. And we're coordinating this effort with Utah State University. They have a Hot Topics grant, I believe, to do a numerical model for this site. So we're coordinating this effort with those folks to get the biggest benefit for everybody. Right now, you can go to our NWIS webpage and access the flow data that we have now that we're putting on the web, and the monthly discharge measurements are there as well, which are what I've plotted here. So here's discharge in cubic feet per second on the y-axis, and then I have time. And then the blue circles represent south to north flows. The red circles are north to south flows. And then the light gray on this plot is the head difference between the north arm and the south arm. And you can see we have data from when that new breach opened up. So the south flows into the north arm were very, very high. You see those flows ramp down as that head difference ramps down. And then you see where we picked up flow from north to south later after the new breach was opened up. And then just to bring your attention to the more recent data, right now we have north to south flows hovering in the few hundred cubic feet per second, and south to north flows are a little bit higher than that. So these are the monthly flow data that we're collecting at the new breach. Obviously key to managing that location. And then just to remind everybody, we're also monitoring nutrients at our inflow sites around the lake. So we have 6 sites that we're sampling approximately every 6 weeks. And this sampling effort began in 2011. So this is a very long-term record that we've established that gives us a sense of nutrient monitoring. We're going to talk a little bit more about that. It ties right into a paper that Dave Nafs is working on right now for nutrient loads to Great Salt Lake. And then just to remind everybody, there's also open water nutrient sampling happening on the lake. This we do in coordination with John Luft and his group. They visit these 4 sites indicated on the map every month, and they sample at 2 different depths. So there's a shallow and a deep sample, and we send the samples in, and they're measured for nutrients at the USGS National Water Quality Lab, and then we'll measure also density and then compute salinity with Dave Naf's equation of state for those samples. So this is another long-term monitoring effort that's going on that is key to understanding nutrient mass balance in Great Salt Lake. And this plot is just to give you an update on what the density and therefore salinity looks like in the south arm of Great Salt Lake right now. Remember, salinity is computed from density values using the equation of state. If I put up this is density data I'm showing here, but if I put up a salinity plot, it would look very, very similar to this. So we have density on the y-axis in grams per cubic centimeter. We have time on the x-axis. The circles are for deep sites, 2565 or 3510. You can look at the legend here. The triangles are shallow samples. And then the light gray is the elevation of Great Salt Lake over time. So we're all familiar with this plot. We've seen the development of the deep brine layer after the new breach was opened up. And we've watched the density or salinity values increase at depth, which correlates to the development of the deep brine layer. And then we've seen the response of the shallower water over time since as well, which are represented by the triangles here, of course. And just to note, you know, after opening of the new breach, we had a little bit of a freshening of the upper brine layer water. The density values are relatively low compared to historic values, say back in 2012. And more recently, the density values have been increasing slightly. But this, you know, this is a seasonal thing that we see every year as water levels decline. In Great Salt Lake, density values tend to climb. But watching these density values or salinity values over the next few years will be pretty critical as we're in this low water kind of paradigm. So it'll be interesting to see how this data develops over time. Okay, and that brings us to an update on what Dr. Dave Nafs has been up to. As you guys all know, Dave Nafs is in emeritus status right now, if I've got that right, Corey. But he's with us. He's working on Great Salt Lake. He's thinking about Great Salt Lake. And so what he's doing now is he's updating a nutrient mass balance paper that he published in, I think it was 2016. And it has data from 2010 to 2014. He's working on the more recent data from 2015 to 2018. And his whole objective here is to compute nitrogen loads to Great Salt Lake. He's going to calculate monthly nitrogen pools in the north and south basins of the South Arm. So, you know, he's talking about Carrington Bay, you know, up in the northwest corner of the South Arm, and then the main body of the South Arm of Great Salt Lake. He's gonna compare those monthly nitrogen pools in those bays to his previous paper that he published, and he's going to document the impact of the new breach opening on nitrogen distribution in the lake. And so he's working on that now, and he's making some progress. And obviously, the end goal here is a journal article. And he sent a few plots for me to share with you guys today. So here he's plotted total nitrogen annual loads via inflows to Great Salt Lake for he's got the old data, 2010, all the way out to 2018. So he's showing the more recent data. So the y-axis is just, excuse me, total dissolved nitrogen in kilograms, and we have obviously, you know, year on the x-axis. And he's divided up each bar into the various inflow sources. So the Weber River's in pink, Farmington Bay outflow blue, yellow's Bear River, and green is Goggin drain. And you know, very interesting things pop out. Obviously, you see 2011 and 2017 had high nitrogen loads. These were good water years. We had good runoff those years. It's interesting, and we'll have to look at the data a little more closely to see this, you know, apparent little trend increasing for increasing loads through the 2013 to 2016 period to see if that correlates directly to just inflow volumes. But interesting trends, and we're lucky to have a long-term data set to do this kind of analysis. And so now at this point, we know that you know, Bear River Bay, if we were to take the load over the entire 9-year period that he shows here, Bear River Bay is you know, the biggest source of nitrogen to the South Arm of Great Salt Lake. That's followed by Farmington Bay and Goggin Drain. So you know, if people are thinking about nutrient loading to the lake and potential impacts looking into the future, now we at least know how to kind of prioritize the basins that we look at really closely. So Bear River Bay is one to keep an eye on, if as that is the largest. Well, they're all a significant source, but here at least we know the relative difference between the two, or between the 4 different inflows. So valuable work. Here, Dave is showing us the nutrient gradient development at site GSL 2565. So that's in the northwest area of the South Arm, closest to the railroad causeway. So the top plot is showing total nitrogen for dissolved or for filtered samples in milligrams per liter. We have time along the x-axis. Red circles are deep samples. Green triangles are shallow samples. This this first line is the breach new opening, and then we have the north to south flows that were detected at the new breach. Bottom line is we can see very clearly accumulation or a nitrogen concentration gradient as the deep brine layer begins to form at this particular location, and it correlates very nicely with specific conductance profiles measured at this same location. And so you see this red area here is development of the deep brine layer, and so this correlates really nicely to this nitrogen gradient. And so that's the point that Dave is just making here, that the total nitrogen gradient is very similar to reestablishment of the density gradient. Same plot for GSL 3510. The takeaway here is the reestablishment of the total nitrogen gradient is similar to 2565 in terms of the timing, which is kind of interesting when you consider that reestablishment of the density gradient was a little bit delayed relative to GSL 2565. Okay, so that's kind of a shotgun blast update on some of the monitoring that I'm responsible for covering here in this presentation. And now I'm going to turn it over to Christine Rumsey. I'm going to stop sharing. We'll let Christine take over.
Hey, and Ryan, just real quick, there was some questions in the chat about just cumulative flows, you know, and those are things that could be calculated from the data that we have available on our website. And maybe for the next TAG meeting, we could go through and do that, Ryan, where we could, and I think we've done that in the past, where we show like the total inflow to Great Salt Lake from all of the gauges, and then we could also show the net north to south, or the net flow between the north arm and south arm.
Yeah, absolutely, something we can do for the next meeting.
Yeah, so we have all that data, and it's available on our webpage. But yeah, we can go through it. We can go ahead and do that next time.
Thanks, Corey, for responding to Krishna's inquiry. It looks like the only other one was Ann's question about the Goggin water going into Farmington Bay as far as nutrients are concerned.
I'll leave that one to Ryan or Christine.
Let's see. I'm trying to bring it up here. All right. Help me out. What is the question directly? I'm scrolling through the chat.
Under Ann, there has been work done to shift some Goggin water to go through the WMA into Farmington Bay. Is this a cause for concern for any nutrient loading?
Or any other, you know, worries, concern for where the water goes. The thought process to shift that water was because Farmington Bay is much more productive for migratory birds than Gilbert Bay, you know, at least for nesting, that Farmington Bay might need more water.
Yeah, go ahead, John.
Oh, I was going to say, might even ask Becca Downer too, because I know there's some concern with algal blooms as well, especially with the lower water levels in Farmington Bay. That's become an issue, as it would. Unfortunately, if we had higher lake levels, that probably wouldn't be a problem. But I don't know if Becca's still on, if she wants to comment on that, and then you as well, Ryan.
I'll just jumping in. My only comment right now at this point is that's why we're doing this kind of monitoring, is to watch what happens to these loads as management decisions are made. So time will tell, and hopefully the data will help us understand impacts.
And would you mind repeating that question again?
And so Ann said there's been some work done to shift water from the Goggin into Farmington Bay, and is that a cause for concern with the nutrient loading there?
Yeah,
And
I think
yeah, go
what
ahead.
Ryan said summarized it pretty well. Is we have yet to see, you know, in talking with Jason that's there now, they build that concern about the algae blooms into their water management strategy, and you know, where the primary concern is making sure they have enough water to actually meet their management goals. We really need the support to see, like, well, what's also happening with the nutrients, because it's a little bit harder to tell right now.
Great, thanks. And then it looks like Chris, do you want to, I didn't read through that. You want to ask your question as well?
Yeah, I just basically was wondering, you know, what the implications are. Just thinking to the Bear River Development Project, and you know, if that would result in enough, you know, removal of nitrogen from the system that it would have ecological implications for, you know, brine shrimp productivity and the cascade that occurs after that.
So this is Ryan, and we're a scientific data collection agency, and that's exactly why we're putting this investment in with our state cooperators to have a handle on this. And at least now we know that Bear River Bay is an important nitrogen source for Great Salt Lake. So again, it's one of those things where the data will tell the story.
Yeah, and I think that emphasizes the whole purpose for our program, as well as what we'll get into with Mike's later presentation. Is it's our job to provide this information, and the decision makers can take the information that we collect and provide and do with it with a little more understanding of the effects of what could occur. So,
Thanks.
all right. Well, thanks, Ryan and Christine. It looks like your turn in the three-pronged attack.
Great. Can you see the slide?
I can now.
Great.
It's showing, it's not in presentation mode.
Okay, let's see if we can get that. There we go. How's that?
There we go. Perfect.
Okay, great. So I'll just provide a kind of an update on the status of this project that was funded last fall, where we're trying to quantify nutrient mass and internal cycling within Great Salt Lake. This was a very ambitious project, and it relied on a team of folks at USGS. So everyone listed here was really critical to get this work done. And then along the way, we built collaborations with Soren Brothers at Utah State University, and also with Bonnie Baxter at Westminster. So I'll just kind of move forward and share what we've done thus far. The whole motivation for this work really stems from the importance of the lake for various uses, aquaculture and habitat. But there's a kind of a knowledge gap in what controls nutrient availability and as nutrients drive the entire ecosystem. And so what we know is that nutrients are added to the lake from river inflows and from atmospheric deposition, as well as maybe some from groundwater. But there's also a large amount of nutrient mass that's just in the lake already, and it's being cycled through various pools. And so what this project really tries to do is kind of answer or work toward answering these big picture questions of where nutrients are in the system and how they're cycled. And we know that cycling occurs through the ecosystem. Nutrients are uptaken by algae. Algae then feed the brine shrimp. But then what we don't know is what happens when this organic material starts to die and decay and sink to the bottom of the lake. Are these nutrients kind of buried in lake sediments? Do they undergo chemical transformations that then that kind of cycle back up into the upper brine layer, where they're again available for organisms? Or are some lost to volatilization? So again, these are the big picture questions that we're working toward. How that translated to specific objectives in our project are that we are trying to quantify the nutrient mass from multiple pools. So taking samples of the water column, the sediment, the pore water, the biota, and just trying to begin to understand how nutrients are distributed within this entire system. And then from that information, estimating the amount, or to the best of our ability, estimating how nutrient flux occurs between these different reservoirs. And then finally, estimating the amount of nutrient that's buried in the sediments. Again, trying to get a handle on when nutrients are deposited to the bottom of the lake, to the lake bottom, are they being removed from the system and no longer available, or is there some indication that they are being recycled back up into the water column and then again used by organisms? And so how we tackled this was with a huge sampling campaign that was conducted this summer. From this map, you can kind of get a sense of all the sampling sites we were looking at. For example, the open water sites, which are shown as the purple dots, these were our open water sites, and we collected a large number of samples at each one of these, and they represent both deep sites and shallow sites to better understand the variability across the lake. We collected lake sediments, sediment, pore water, particulate matter, or ceston, which would represent our phytoplankton and maybe bacteria. Brine shrimp, we sampled water from the upper brine and the deep brine layer. And so that these purple dots were really intensive sampling locations. In addition to that, we wanted to quantify the rate of material deposited through the water column. So if you just think of sort of like dead brine shrimp or fecal pellets settling through the water column, we wanted to measure the rate of that. And we did that with sediment traps at 4 locations shown by the kind of the black triangles in this map. We also leveraged our ongoing monitoring from the river inflows to continue to collect nutrient data there. And then we also developed a network of atmospheric deposition traps, which are shown by these yellow diamonds, and are scattered at 9 locations around the lake to try and begin to understand and measure the material that's deposited through the atmosphere and what the nitrogen loading, or not nitrogen, the nutrient loading in that material to the lake would be. And so, like I said, we kind of tackled this effort throughout the summer. There was ramp up in July, huge sampling campaign in August, and then efforts have sort of continued through September, October, and even into now. So when we would get to each of these 10 open water sites, this was kind of the list shown on the left of samples that we collected at each site. This was a huge effort. It took a day per site to collect all this material. But again, just linking back to our fundamental question, the idea is to collect this material to quantify the nutrient mass in these different samples to begin to understand how nutrients are distributed throughout the lake. And so we would get to a site, we would sample all of these different things. Sediment, we extracted pore water from the sediment. We measured the sediment slurry, which is the material at the sediment water interface, kind of at that lake bottom. It's a real slimy, sludgy material. We collected really detailed water quality profiles. Every 20 centimeters, we were measuring dissolved organic matter, chlorophyll A, turbidity, along with kind of our more standard parameters of specific conductance, dissolved oxygen, et cetera. We collected water samples from 4 depths in the water profile and the vertical profile. For deep sites, we collected 2 in the upper brine and 2 in the deep brine layer. So really trying to understand the concentration gradient of nutrients throughout the water column. We're also pioneering the use of sulfur isotopes in the upper brine and deep brine layer. And this is really to try and understand the extent of mixing that occurs between the upper brine layer and deep brine layers. From kind of some of the plots that Ryan showed, we can see that the deep brine layer really concentrates nutrients, both in terms of nitrogen and phosphorus. And so one fundamental question we'd like to understand better is how much mixing is happening between those 2 water bodies, because then that would feed into the upper brine layer where phytoplankton and brine shrimp are. And then, of course, we also collected samples for ceston or particulate matter, which would include our phytoplankton, and then also for brine shrimp. And so again, we had a whole field crew who would go out, or 4 of us each day, who would go out, collect all these samples. The end of the day, we would head back to the lab, where we had a lab team waiting to help us process these. We had a lot of filtering to do at the end of the day for chlorophyll and total particulate carbon and nitrogen. We had extractions to finish up and separating solids from liquid. And so a huge coordinating effort with this. And that this, again, was our open water, those 10 open water sites. And in addition to that, this was a pilot project we did in July to try and capture the upper brine layer, deep brine layer interface in more detail. And this was something that this group really wanted to take a closer look at. And so we figured out a way to do this. We deployed these SNAP samplers, which are traditionally used for groundwater, but I think we pioneered their use out on the Great Salt Lake. The manufacturer had never seen this before, but we basically just strung them in a series and attached them to an anchor and a buoy assembly and deployed them for 24 hours at 2 locations on the lake. We came back the next day and we were able to capture these sort of parcels of water across the upper brine layer, deep brine layer interface. So you can kind of see in this photo at the left, the anchor that would have been sitting at the bottom. And we were capturing kind of the bottom 5 to 6 feet of the water column to really quantify the concentration gradient of nutrients across this interface. So we're pretty excited to look more into that data and see what we can learn from mixing in the upper brine and deep brine layers. We also, as I mentioned, deployed sediment traps to try and quantify the amount of organic material that is settling to the lake bottom and the rate at which that happens. These traps were deployed at 4 sites in the lake, as shown in the map on the bottom right. And this was a little tricky because, sometimes research projects, they deploy sediment traps for inorganic materials, and it doesn't really matter, what happens to them while they're still in the lake. But in our case, we were capturing organic materials. So again, decaying brine shrimp and a lot of fecal pellets that settle into these traps. And so the challenge was, how do we preserve that material in situ? Particularly, we actually have video of brine shrimp swimming in and eating that material if there is no preservative and or some kind of chemical to keep them out. And so we used work from Wayne Wurtzbaugh and what he has done in the past, and we made up some hypersaline sodium chloride solution and used that to trap a formalin preservative at the bottom of each of these traps. So then when we deployed these traps, we could preserve the material in situ. So we had some struggles along the way. We had to practice this a couple times, but in the end, I think we got some really good samples. And then finally, we did collaborate with Soren Brothers at Utah State University. We put on some of his mini dot continuous DO sensors on 2 of our traps, the 2 at the south end of the lake, for his study and his looking at primary productivity in the lake. So it was exciting that we were able to collaborate and kind of be more efficient in that way. And then finally, I'll just close with the atmospheric deposition traps. Dave Naffs in his previous reports has estimated nitrogen deposition from the atmosphere in previous reports, and that was based on model data. What we were trying to do here is to actually collect material and measure it, and we did that by deploying atmospheric deposition traps at 9 locations around the lake, as shown in this map. This is the spatial distribution we were working with. And we manufactured, Andy Carlson from our office manufactured these sort of trap stands. They're like these metal holders that then would served as holders for these plastic funnels, which then would sort of direct the sample into these sample bottles. So we piloted this new methodology and were able to collect material from atmospheric deposition around the lake. And so in all, I'll just say that the sampling is complete, and overall with the complexity of the samples we were dealing with and the challenging logistics, I think I'm really pleased with how it went, and it was a great opportunity for us to learn more about the lake. In the end, we collected almost 190 samples for over 1,200 analyses. And so I think this will really drive our understanding and our knowledge of nutrients in this system. It was a really large data collection effort. And then moving forward, where we're headed is that we still have some remaining samples to send in for analysis. We did do all this during the pandemic, and there's a lot of samples that we had to rely, a lot of different kinds of samples. We had to rely on a variety of labs. And so, you know, we were dealing with pandemic challenges, as well as all of the labs that we're relying on we're also dealing with pandemic challenges through this time. And so there's been some delay in getting analytical results back, but we do anticipate getting those in the next month or two. And then we will begin just quality assuring all the data, again, making sure that the data is high quality for all these different sample types that we collected. And then this is the exciting part then, is moving into answering the questions that I outlined at the start. That is to quantify the nutrient mass in each pool in the lake, really try and understand the nutrient distribution in this system, and then quantify the flux rates between the pools, trying to understand the cycling and the rate of cycling that's happening, and then finally estimating whether nutrients are being removed in the sediments at the lake bottom, or whether there's evidence that they're being cycled back up into the water column. And so that's what we're going to be working toward in the next several months, to quantify these things and to begin data interpretation to further our knowledge of nutrients in Great Salt Lake. And the two main products that we're shooting for are a data release and an USGS Speak. That's basically just a way to store all this data we've collected and make it publicly available. And then finally, preparing a journal article to document what we've done and our findings. So thank you.
All right,
Great.
thanks, Christine. And just to clarify on that data release for everyone, the data information that we have that can go into NWIS will be going into NWIS. And then the other information will be in this data release that will come out via ScienceBase. Is that right, Christine?
That's right, Corey. Yeah, we may find a way to shove a lot of it into NWIS, but I don't think that's going to be possible yet. So I think we should all anticipate a data release.
Yeah, NWIS, which is the USGS National Water Information System database, does have some limitations, and some of the stuff that Christine is doing here is outside of the normal realm of things. And so, yeah, having it released via ScienceBase is going to be the best way to do that. All right. Does anybody have any questions for any of the three of us?
Yeah, awesome job. Is there anything that anybody wants to bring up? We're a little bit behind schedule, but we'll cover what we can. All right, well, we'll go ahead and transition over and let Mike present. And basically what I want to reiterate from the very beginning is that this is research that is being proposed and has to be vetted through the Research Council. So I just wanted to make sure that if there isn't any comments, I mean, we did this similar thing with USGS last year. I think you guys did a great job at putting together something that was a monumental task as far as getting any information on nutrients. And now I kind of want to do the same thing with Mike's work. And he was going to provide a quick presentation. And then if there are any input or comments or things, and we don't even get to those during this meeting, go ahead and send those questions or concerns or ideas to me after the meeting. And that way, when I take this to the Research Council, then I'll be sure that I'm covering everything that was addressed in this meeting. So Mike, Do you have a presentation, or were you just going to provide the information?
I'm just going to talk. You all hear me fine?
Yep.
Yep. Okay. Well, I'm here in a room at Utah State University with my grad student, Mark Bell. I apologize that the image of me is smaller than other people, but my wife always tells me that I look best when I am small and fuzzy. And so that's the benefit of having a small image of me. John Luft and I have been discussing for several months now where we want to take the bird research on the Great Salt Lake. There are several people here that I don't usually attend this meeting, and so I should probably introduce myself. I'm a professor of wildlife at Utah State University, and I have worked for many years on bird use of the Great Salt Lake. And so we're at a period where it's a good point to think about what we want to do in the future. And what John and I want to propose is that we start to develop a bioenergetic model for the Great Salt Lake. And by the Great Salt Lake, I mean both the bays, the pelagic bays, the less saline bays, the mudflats, the brackish and freshwater habitat around it, the entire ecosystem for the Great Salt Lake. And what a bioenergetic model does is it basically converts everything into units of energy. A bird is no longer a thing that has feathers. It is a thing that expends energy or consumes energy daily and expends it to survive. This is referred to as a daily energy expenditure. It's the amount of energy that the bird needs basically to survive, to do things. Most of the birds, for instance, that are on the Great Salt Lake that stage here molt. And so it includes the amount of energy that birds need to molt, the amount of energy they need to survive, to complete their activity patterns. And so birds are energy expenditure. And we combine that with what is called bird use days, which basically is the number of birds that are on the Great Salt Lake times the number of days they're here. So for instance, we have eared grebes. Let's say we have an average of 2 million eared grebes on the Great Salt Lake on an average day in the fall, and they're staging here, and that's about right. Let's say they're here for 60 days. That is then 120 million eared grebe use days. And that is the amount of energy basically that the Great Salt Lake needs to provide to sustain this current breeding population. It is basically how much energy the environment, the habitat of the Great Salt Lake has to be able to produce, or the bird population, the eared grebe population will collapse. So we have energy, we have bird use days, so we can basically calculate what that total amount of energy is that the Great Salt Lake needs to produce. The main part of a bioenergetic model, though, is calculating how much energy the Great Salt Lake actually produces. This is determined by going out and determining where a bird is foraging, how much of that habitat exists around the Great Salt Lake, and then to go out and measure how much energy is produced in that habitat. So let's say, for instance, we have a bird that forages in water that is, it's a shorebird that forages in water between 5 and 10 centimeters deep. So we'll map that habitat, determine the number of hectares that are out there, go out and measure the energy that is produced in that habitat. And in this case, the energy that's produced is, remember, these birds are only consuming certain prey items, what is the energy biomass that is produced of those prey items that are important to that bird in the habitat where it forages. And so by doing this, basically, we can look at the Great Salt Lake to see if it is producing the energy that the birds need, or if there's bottlenecks occurring where there is bird species that is using the Great Salt Lake, where basically food production doesn't meet its needs or is very closely doing so. An example of this, of a bioenergetic model, and the usefulness comes from Forsyth National Wildlife Refuge in New Jersey. That refuge is primarily managed to provide a staging area for American black ducks. Black duck populations have been declining for decades for a number of reasons, and it is black ducks that this refuge basically is managed for. Well, they did a model, I should say the black duck stage on Forsyth. They come in August, stay until maybe mid-October, and then they leave, move further south. And so they basically looked at where the black ducks were foraging on the refuge, what they were eating, determine the amount of energy or basically food that the black ducks were using on Forsyth. And what they found was that by late October, the amount of food that the refuge was producing had been consumed by black ducks. By October, basically, there was no food left for the birds. And so maybe it wasn't that they were moving because of migratory pattern, that the refuge had simply run out of food. They provide food, it's a standing crop, but by mid-October, it had grazed down to nothing, and the birds left. And we may find that that would be a bottleneck, that perhaps the birds would stay there longer, but there's simply not enough food being produced in that refuge. And we may find similar bottlenecks on the Great Salt Lake. So that is what we're proposing. And it's a simple introduction to it, but bioenergetic models in concept aren't very difficult. It's collecting the data to accurately be able to gauge things like bird use days, which means going out and monitoring how many birds there at bi-weekly intervals, where they're located, what the habitat they're using, what they're foraging on, and then going out consistently to measure energy production in those habitats that are used by the birds. So with that, I would be happy to open it up for questions. And John, I hope you'll, if I don't know an answer, I hope you do.
Yeah, well, I probably don't, but I think this is actually similar in the undertaking that USGS made with, and Gary has done with the model that USGS has taken with the nutrients. This is a big project, but it is crucial as far as timing goes, just because of the lack of water. One of your previous students, Maureen Frank, was showing how important the bays were, especially Ogden Bay, Farmington Bay, with respect to phalaropes. And I think this is similar, just an expansion of different, and primarily we're looking at shorebird species with this research. There's been more work done on waterfowl and bioenergetics, and I think less done for the shorebirds, and understanding the impact of less water in these bays specifically and how that affects the available forage base is what we want to understand and what we want to try to inform decision makers what impacts the lack of water is going to have on for future bird use here at Great Salt Lake. So that's, I think, the focus of this research, and hopefully that's clear to everyone. But if you have any questions, please go right ahead.
Well, we are just starting this, but I can give you a local example of a bioenergetic model. It is what this group has done for eared grebes. We have, through work of John Neal and others, we know how many eared grebes are out there on the Great Salt Lake. We know how long they stay. We know how many bird use days there are. We know what they eat, primarily brine shrimp. We know how many brine shrimp there are in the Great Salt Lake. These are adult brine shrimp, and through the work of Gary and others, we know what impacts brine shrimp numbers and densities. And so we've developed basically an energetic model for eared grebes. We've done one for phalaropes also, but it basically allows us then to look at the Great Salt Lake and say, well, gosh, for eared grebes, we need to make sure that brine shrimp population is healthy, or those eared grebes are going to be in trouble. And what we're proposing to do is expanding that model, developing that model for other birds on the Great Salt Lake.
Hey, Mike, this is Thomas. I have a question.
Go for it.
You mentioned that you were going to do this, lake-wide in all the different bays. Will you have enough resolution to where you could identify why certain groups of birds may migrate from one bay in the Great Salt Lake to another bay, or one area to another area, as a result of these food limitations in that may be more localized?
We could, if that turns out to be a specific pattern that they're following, with both eared grebes and the phalaropes, what we find is they move around the Great Salt Lake to where adult brine shrimp, or in the case of the phalaropes, where adult brine flies are at the highest density. They want to forage in very abundant areas. In fact, there has to be a high density of adult brine shrimp in the water column for the eared grebes to survive. They got to catch them quickly. They got to catch something like 26,000 a day. And if you figure that number of hours, that is an awful lot of fast eating if you're going to eat that many every day. But yes, we can do that. But I think from the standpoint of the Great Salt Lake and this tag would be to look at the Great Salt Lake as a whole and ask the question, for a species like, say, American avocets, what is our capacity to feed American avocets? Are we meeting that easily? Or have we got a situation where we're like Forsyth, where avocets leave because they run out of food?
Now, I would agree with you that that's important, but I would also think that, and I think you saw that with the phalaropes, is that certain bays of the lake may be more important or less important at different times of the year, and be able to support certain populations of birds, where the birds may have abundance at one time of the year and not really worried so much about where they are. In other times, certain bays of the lake may be much more important for that species. I think you show that with the phalaropes, with Maureen Frank's work as well, that Farmington Bay at some point was quite important. So I really like the idea of what you're doing. I just do think that having that resolution to be able to identify migration of these birds within certain bays of the lake is also important.
Yes, we actually intend to do that. Maybe I didn't make that clear, but we intend to go out and locate birds, count birds like every 2 weeks throughout the period they're here. And so we expect to be able to monitor just that, to see if in fact they're moving around. And ultimately, since we're measuring food availability at the same time, it could be that, like the phalaropes move around. For a while, they were eating adult brine flies, and they were over the bioherms then, where adult brine flies were more abundant. Then later on, as you point out, they moved to Farmington Bay, where they were eating other things. There aren't very many brine flies or brine shrimp there, but what they were eating there were corixids and things like this. So they moved around. We were able to monitor that, and we intend to do so in this model too.
Yeah, and I think there's also a temporal aspect to this research that is related flyway wide. So there's timing based on migration patterns of different species that need to be addressed. Maybe there's water in a certain area and provides food, and there's no birds to take advantage of it. There will be a timing aspect here that may give us an idea of when it is best to have water in some of these bays or in the impoundments that help us understand a better way of utilizing the water that we have available to us, that ultimately plays into a lot of legislation as far as water banking and things like that's concerned.
Well, it may be, for instance, an example where prey densities peak 3 weeks after an impoundment is flooded, and it drops off then. And so if that's true, then you would want to flood that impoundment about a month before you need that water to, say, support phalaropes. Phalaropes are here for 2 months, which is in July and August. They come, they're here for 2 months, and they leave. That's when, if your interest is phalaropes, that's when you want to make sure that you have the food that they need.
Corey, you had something?
Yeah, just real quick, and this kind of really just dovetails into a question that Chris Klein has in the chat here, and I was kind of thinking along the same lines as, as far as the boundary of this, how does the Bear River Migratory Bird Refuge fit into this? I mean, is that inside your boundary? Is it outside? And Chris goes on to ask in here, is there a way that Fish and Wildlife Service could help on that?
Yes, it's really bound by the areas, the refuges, Willard Bay, the things that are dependent upon water flowing into the Great Salt Lake, that movement of water. And so there are a number of waterfowl management areas, the Bear River Refuge, where they have impounded basically water that's flowing into the Great Salt Lake. And those would be part of this system that I'm talking about, of the quote unquote Great Salt Lake, the Great Salt Lake in the marshes, because the water flows through that and then it flows into the Great Salt Lake. As an example of that, we found out that Willard Bay has a sheet flow of water that flows across it in the summer. And there are thousands of eared grebes that nest out there. and they require a certain depth of water, which we determined to be about 20 to 30 centimeters in depth. And that's flowing out through Willard Bay out into the Great Salt Lake. You've got to maintain that depth to have eared grebes. And so water has to constantly flow through that Willard Bay. And so they're linked in the same way the Great Salt Lake is linked, in that they need fresh water flow through Willard Bay, just as the Great Salt Lake needs fresh water flow into it.
So I don't, and I mean, I don't want to belabor this at all or cut anything short, but Chris and Lynn and Thomas all bring up good points. And I think all of those things are going to play into this research. Every one of those questions need to be asked and answered, because each area around Great Salt Lake is different. And they're more important to different species of birds, and that can change from year to year. So we just have no information, or I mean, relatively little information on this, and we have to get started at some point to help understand what the lack of water does and what is available to these birds. Flyway wide, what is the need for specific species at Great Salt Lake, and what are we able to support going into the future and help inform decision makers of what our habitat limitations are. So hopefully that makes sense. And this is not going to be a simple 2-year project. This is probably, I'm guessing, decades, and we'll slowly start chipping away at it, similarly to what we've done with every other aspect of our program. It just takes a lot of time, but if we don't get started soon, we're going to be behind the 8 ball.
Mm-hmm. John, I was just going to say, a couple things in response to Thomas's question. I think that there's kind of a resolution issue with some of the questions that he asked, as far as just the specifics of, why birds move around on the lake. And so kind of from an overall energetic perspective, it may be, that something like this kind of speaks about things more on a lake-wide basis, or kind of larger subdivisions of the lake. But on the other end of things, I think that the information would be really helpful for management of the, like the refuge and the waterfowl management areas, particularly if we're in a situation where there's declining resources and kind of have to figure out how to optimize, okay, this is the amount of water we're going to get. What's the best way to use it to get the best productivity for birds, and then balance that with the other uses. But yeah, I think this is really good. And Mike, if, I'm sure that you've got a long-standing relationship with the refuge, but, if there's any way that I can help, facilitate or get involved with this, definitely let me know. So
thank you.
I think it'd be important. It's an important issue. So thanks.
That's perfect, Chris. You're going to be the one speaking to the Research Council.
I like it. Well,
is there any?
I was just going to say,
oh, go ahead.
My research approach has always been very adaptive. I want to do research that is useful. I enjoy coming before the Research Council. Any suggestions of what we should be doing, comments, concerns, you can email me, or you probably have John Luff's email more than mine. Either one of us, I would greatly appreciate the comments, and I'm sure John would too.
Yeah.
So I have a question. This is Ann Neville.
Wait, first I'm going to say something. Ashley asked about historical background. I think that's going to be the first step in our in this process. Is reviewing literature that's already out there. So hopefully that answers that. And go ahead, Anne.
Yeah, one of the things that I think that, at least I recall, and my memory could be extremely faulty, is that in an energetic study, we're limited to whatever time that we have that we're collecting data. So it could be, you know, some birds are more cyclical. And so how many years are you going to try to collect the data with the birds and the bugs? Just because I know it's hard. I mean, this is a huge undertaking, and just is a snapshot in time. I think it's way better than nothing. But is it going to be enough to really make informed decisions?
Well, we view this as a very long-term project. As you all know, there's great variability in the Great Salt Lake among years based on water levels. With populations, what happens on the Great Salt Lake is impacted because other saline lakes are becoming less suitable. And as that happens, as we see with eared grebes, you know, we used to have a lot of great eared grebes stay on the Salton Sea. And now the Salton Sea is so salty that the food that the eared grebes used to go there to forage on no longer occurred there. They're no longer found on the Great Salt Lake. And so those birds are moving elsewhere, and a lot of them are moving here. So we envision this, right now we're talking about a 5-year time horizon, but in reality, this is a project that's going to go on for many, many years, because, you know, the Great Salt Lake is a big system. It's going to need years. But basically, in an energetic system like this, in terms of local versus lake-wise, you go out to these areas at weekly or bi-weekly intervals, and you collect at least 50 core samples every time you go out. We would do this probably at a dozen or 2 dozen sites on the Great Salt Lake. So you determine what is produced by the Great Salt Lake by basically adding up what's happening at 20 different sites. And so we already plan to do things like look at how food availability varies from one site to another, and then to sum it up to get the Great Salt Lake. But that individual variability is already factored into our model because we realize we have to do that.
Well, just remember, mosquito abatement skews your bug samples big time.
That should be another aspect of this research, and Ashley has brought that up with some of the questions that they got from the wetlands assessment. So every one of these things, and Robert even included another question in the tab here, that every one of these things need to be addressed. It's similar to the nutrient work that USGS is doing. Yes, we have to start somewhere. They took a snapshot. Now you just expand on the information that you collected. This is going to be similar. I see this outliving my career because I don't think there's ever going to be an answer or an end to this this project. There'll still be information that we're going to need going into the future. So, but we have to start somewhere, because right now we don't have a basis for making management decisions that are founded in good data at this point.
Hey, John, this is Heidi. Can I just add a comment?
Yeah.
And Mike, I think this is a really wonderful question to be looking into, and it's very, very important. And I just wanted to say that I've been conducting research at the Gilmore Sanctuary for the last couple of years, looking at characterizing shorebird habitat and particularly their foraging habitat, because we want to try to understand how to better manage our water to provide the most, production and macrovertebrates, thinking that that would attract the birds. But one of the underlying questions is, why does one site that seemingly has the same conditions as another site, they almost look identical, why does one draw attention and provide the absolute perfect setting for foraging birds and not the other? And I bring this up because I would say that you cannot underestimate the level of variability that you'll be finding in these areas. And I echo the sentiment about the importance of resolution that Thomas raised, and also that Anne raised, and that you only have the data that you have. And of course, that's true in any research effort. But that said, the birds do move around all, and you almost can't get out there often enough and take enough samples. So I would just keep an eye on that level of variability.
We'll do that. Hopefully the bioenergetic model would suggest that, or look at the question of whether they're moving because of food availability or some other reason. And with the phalaropes, they were moving because of food availability. They moved to the part of the Great Salt Lake where they find the best food resources.
So Thomas, I saw that you had your hand raised also.
Yeah, I did, John. I just want to make another comment. I think that a lot of work has been done on the grebes and the phalaropes, and obviously with the grebes, we've really benefited from that synergy with Gary's work. And I think you're on the right track. I do think that we need to expand and get a better understanding of a number of different and other species around the lake. And I think we've seen that many of the different days within the lake are important for certain species. And I'm definitely very supportive of what Mike is proposing and what you're doing.
Thank you, Thomas. I might point out that we're doing this in large part because that has been a recommendation of this tag group for a couple of years now, that we needed to do more than just work on eared grebes. And so we, in fact, have followed the advice of this group. And what we're proposing is to continue that trend. So just another case where we listen to what this group says and try to adapt our research. And I know that Gary does that, and Corey. It's not just a case of this group listening, but what we say, but we listen to what the members of the tag say and try to follow their ideas, because those ideas are often correct.
Well, thank you for doing that, Mike. I'm very supportive, and I think most of us that have been with this group for a while understand the importance of the long-term research and understand that inevitably some of the research that you embark on is going to require work over multiple years, and that's just the nature of what we do around the Great Salt Lake. And again, I'm very supportive of it.
Thank you.
Yeah, and there's been a couple other more observations in the chat box, and I think every one of these, there's so many different variables that are going to have to be looked at. That's why I say this. There is no way that you can get a snapshot. I think the emphasis of this entire project is on water, and how does water impact the forage base for all of these birds, and that's going to be the focus of a lot of the research. I think what Heidi was talking about is just because there's 2 inches of water in an area, it doesn't mean that birds are going to come and utilize that. But and a lot of this work isn't going to revolve around the birds themselves, but the macroinvertebrates that are available to them. So there's a lot of different moving parts to this, so it's not going to be an easy fix, and we're not going to have any answers in the next 2 or 3 years, but it'll be a basis for us to move into the future and help us understand what's available here, and hopefully specific to shorebirds, what the requirements are for them, as well as what GSL has to offer.
Yeah, I think what we're all trying to do is make sure that the Great Salt Lake can support the avian populations that are dependent upon it. The concern is, we have 2 million eared grebes on the Great Salt Lake. What happens if brine shrimp populations should just collapse one year? These birds can't fly. That would be an environmental catastrophe. But the case of the phalaropes, they need 1 to 2 feet of water. They can't survive if the water is less than a foot deep. These birds swim underwater. They need water depth to nest. They need water depth to forage. What's going to happen when Willard Bay has just a few inches of water? That's not going to be a good day for eared grebes, or for phalaropes rather, or eared grebes.
So Russ and Pam and Chris all have made comments, and just because I've seen Mike's proposal, right now the emphasis is going to be on blackneck stilts and avocets as far as a species, but there will also be a literature review initial, and I think Heidi and Anne, you mentioned several other studies that have been done and work that has already been accomplished. That will be the responsibility for the initial student that Mike brings on, is to find the data that has already been or the work that has already been done, especially here at Great Salt Lake, and put that together and not duplicate that, but build off of that information. And that I think, especially with the pandemic situation right now, that can be done. That literature review basically can be done right away. So that's going to be the focus, I think, starting off, and then we'll start moving into looking at specific species or suites of species to help us understand what's going on. So hopefully that is a good starting point. I hope that makes sense. And again, we'll take everybody's comment, and Mike will be or the student will be updating us on where this research is going as far as moving into the future.
Hey, John, I was just going to kind of ask that question there. So I'm assuming that there is a proposal, and that you will send this proposal out at least to the official TAG members for review and comment, and yeah, go through that process, right?
Yes, and what's going to happen is because there is the research council meeting towards the end of this month, I have to adhere to their time frame, and then once I kind of get the okay that we are moving in the right direction as far as funding and understanding this proposal, I'll probably send that out. I am anticipating before the next tag so you can review it and then look for comments similar to what we did with nutrient work.
Okay.
Hey, John, this is Thomas. Another comment. I understand that there's a focus on water, and it's obviously very important. But I would think that over time, there may be a link or tie-in with the work that the USGS is doing on nutrients and nutrient cycling as well.
Yeah, absolutely. That's why I think this is critical to get started now, is because I think we're at the beginning of that work as well.
Yeah, and that's really why I asked the question about reviewing the proposal to see what kind of overlap or synergies can be built on this.
Perfect. Yeah. Okay, well, does anybody else have any other questions? And like I said, I'll try to follow up with as we're going through the approval process, that I then provide this information along with the proposal. Given that we'll need to get a student on board to help put together a lot of the details, which is also a difficult part, because they need to know as a student coming in that there is funding available. So that's kind of hard sometimes. Any other questions or comments?
Hey, John, this is Jamie. Have you been missing me? I just put in the comments chat a link to the Salty Science seminars. Lots of you are presenting. It's all about Great Salt Lake and the chapters in the Great Salt Lake biology book. So there's 3 more. Next week is going to be reptiles and mercury issues of Great Salt Lake. There will be a whole seminar on macroinvertebrates and artemia, and one about the roselle tar seeps and north arm, the north arm microbes. So please come. They're fun, short.
Great, thank you. And the link is there, so.
John, I have a comment.
Oh, yeah.
Oh. No, finish, Jamie.
Oh, and we have tons of really cute gifts that you can get if you need some, an Avocet magnet that says Great Salt Lake is for the birds, or 2020 is for the birds. You can also get those too.
Very good. Lynn, go right ahead.
It's always great to have Great Salt Lake swag, don't you think? Anyway, yesterday at the tech team meeting, I announced this publicly. Because of COVID and because of timing of a vaccine and implementation questions, I am going to reschedule the Great Salt Lake Issues Forum to May of 2022. So your dance cards will be free in May of 2021, but I hope 2022 will be just the right time for us.